Decimals are the only math concepts that make you feel like you are doing something wrong, even when you're right. But there is a simple forgotten rule that instantly connects decimal back to basic math. Mastering that rule will end all your decimal mistakes right now. Let's understand what exactly the decimal is. Decimal is a combination of a whole number and a fraction. So, it is basically the way of writing the numbers that are not whole, and it always uses a dot. As it is shown over here, 36.5. So 36 is actually a whole number. The dot represents the decimal, and the number that is after the decimal point is actually the fractional part. If you understand whole number place value, you can understand decimal. They follow the exact same logic, just in reverse. I'm going to tell you simple three-step framework to handle decimal with confidence. Place value, reading and writing, and comparing the decimal. In this place value chart, think of the decimal point as the mirror. So let's think that here we have a mirror. Everything to the left of the mirror should feel familiar. That's the whole number side. Ones, tens, hundreds, and so on. Now look at the right side of the mirror, the decimal side. The first place is the tenths, then the hundredths, the thousands. Notice the THS in all of them. This represents pieces of tens, pieces of hundred, and pieces of thousands, and so on. The key takeaway: every time you move a place value to the right of the decimal, you are dividing by another 10. The system never changes. Now, we will understand the reading and the writing of the decimal. We have basic, simple rules for reading and writing. The first rule says that read the whole number part first. For example, in this number, 42.671, we have to first read the whole number. Say the word "and" for the decimal point. Read the decimal part as a whole number again. And say the place value of the last digit. So for this number, we'll say 42 and 671 thousandths. Why thousands? Because 1 is at the thousandths place. Let's understand the different ways of reading and writing the decimals. So we do not have only one way of reading and writing the decimals, but we have multiple ways of reading and writing. Like over here, 0.6 can also be written as 6 tenths or 0.6. I mean, the way you are speaking, we can write it in that form. Similarly, 2.45 can also be read as 2 and 45 hundredths or 2.45. As you can see, we always read first the whole number. The decimal has to be represented by the word "and." Then we read the number after the decimal as it is, but at the end, we have to just specify the place of the last digit in the number. Now let's study the different types of decimal. The first type is the like decimal. The decimals that are having the same number of digits after the decimal point. For example, you can see over here 2.35 and 4.67. As you can see, in both the numbers, we have 2 digits after the decimal. So when we have equal number of digits after the decimal, it is known as like decimal. The second type is the unlike decimal. Decimals that are having different numbers of digits after the decimal point. For example, 3.2, 4.56, 7.843. We have different digits. That is, 3.2 has one digit, 4.56 has two digits, and 7.843 has three digits after the decimal. Since they have unequal number of digits after the decimals, so that's why it is known as unlike decimal. To compare decimal without error, use the aligned trick. You must look at the place value from left to right and make sure your number have the same length after the decimal point by adding a placeholder zeros. Now, how to compare these two numbers? As we can see, 0.6 has only one digit after the decimal, where 0.60 has two digits after the decimal. So, in this case, first we are going to make them like decimal by adding a placeholder 0. So, if we add a 0 to this number, it will become 0.60. And this number is already 0.60. So this time we'll just forget about the decimal over here and we will compare the two numbers that are given after the decimal, that is 60. Since both of them are equal, so we'll put the equal to sign. Now let's see that how 0.60 is greater than 0.59. So again, how to compare it? The whole number is 0 in both the cases. So we'll focus on the numbers that are coming after the decimal. In the first, it is coming 60 and in the other, it is coming 59. So we already know 60 is greater than 59. So we put that 0.60 is greater than 0.59. Quiz time. Check out the question as shown. Pause the video, solve them, and drop your answers in the comments. Would you like to see a video next on converting a decimal to fraction? Don't forget to like and subscribe to thinkmathic for more simple guides to tough concepts. I'll see you in the next one.